Hi, my name is Djamel Sahnine. I am ATM architect at Frequentis, and I will explain you today what is to be software engineer in air traffic management in our company. Well, when I start to think about air traffic manager, I think you have experienced moments where you are invited in a dinner with friends or with family, and there is always a moment where somebody is asking you, what do you do for a living? And you always find at the table a doctor, a baker, a teacher. I mean, somebody who is actually working, so to say, for the common good of people. And me at that time, before being at Frequentis, being an IT developer, working in various domain, web shop, different application. It was always a kind of awkward moment actually to explain what it is, what I am doing every day. But I have to tell you that since I'm working at Frequentis, I'm really looking forward to answer these questions. Because my answer would be now, I'm making the life of people safer. And this is at the very heart of air traffic management at Frequentis. Air traffic management is simply to make the sky safer. And all of us, software engineer, developer, we are very proud to be part of it. So, in air traffic management, you know, air traffic controllers are essentials. Air traffic controllers are the pillar, actually, to make the sky safer. And they are very well trained to manage complex situations, but they need support. They need tools and technology provided by Frequentis to help them doing this complicated and difficult mission. So making the sky safer means essentially ensuring separation between aircraft. So nothing serious can happen. And to do this, an air traffic controller basically needs three things. He needs first to monitor the situation and understand it. The second thing an air traffic controller needs is to analyze this situation and elaborate strategy and decision, and then ultimately execute this decision. And these are the three fundamental steps in the brain of any air traffic controller. And then the loop starts again. Once the decision is made and executed, we monitor again, we analyze, we execute. And at Frequentis, we actually contribute through our technology to support controller doing these three steps. Monitoring means providing an accurate picture of the situation, the air situation, but also the ground situation where the aircraft are. Analysis means for us decision-making support. So we provide tools to help the controller to make the best analysis and the best decision ever. And then execution, we also provide reliable communication means so controller can execute and communicate its decision to other controllers, but also and mostly to the pilots themselves. Let's look at these three elements. So, accurate position, accurate picture of the air situation means for us providing to the controller the exact aircraft position with the most accurate information. And for this, we develop several technologies at Frequentis. We develop radar sensors technology in order to capture the position of the aircraft. But we also develop sophisticated algorithms in order to process all of this surveillance information coming from different areas, and at the end, providing a unique, reliable, and accurate aircraft position. Combined with flight data, we are capable to provide the controller not only an accurate position of the information, but also augment this information with flight information related to a certain flight on its display. And it's not only about surveillance information. Huh? We're also providing a video surveillance solution. That means we do provide, install camera system in airports. We process this information via complex video processing applications in order to provide the best picture to the controller who can sit miles away. And that's what we call remote tower control. And it's not only about taking a video picture from cameras and displaying it to another location. It is also about processing this information. And for instance, we rely on artificial intelligence algorithms in order to detect interesting information or remove undesired information from the video streams in order to provide always the most useful information to the controller. The second point, decision making and which support tool can we provide? All of this information, surveillance information, video information, flight data information that we have captured is finally used and processed in various applications which will help the controller to make the right decision. Which application are we talking about? First, we provide complex trajectory prediction algorithm. So trajectory prediction is the fact that we are capable, based on the situation information, to predict where the aircraft will be in 5 seconds, in 5 minutes, in an hour. And this information is refreshed every second. And for this, to process this information, it's not only about using situation data, it's about using aircraft model to understand the behavior of the aircraft. It's also about using weather information to understand the effect of winds and temperature and pressure in the behavior of the aircraft. And at the end, this complex algorithm provide the controller an accurate information where the aircraft will be. Then, when we have a prediction, we are capable now to detect conflict. And conflict is the fact that we can predict if there will be a, so to say, dangerous situation in the near future that the controller should know. Dangerous situation means there is loss of separation between aircraft. And since we have future trajectory, we are capable to predict what conflict can happen and what could be their severity. And this helps the controller to make the right decision before the conflict actually happened. And therefore, we develop what we call safety nets. And safety net is easy to understand. It's a protection, so to say, an information for the controller to tell, to predict in advance what could be dangerous situation. We can detect problem of separation between aircraft, but we can also detect abnormal behavior of an aircraft when the aircraft deviates from its route. And we can even check that the information and the clearance information that the controller has provided to the pilot has been executed correctly. And all of this information is processed in order to tell the controller if there is a problem or not. The third thing, and which is very important to us, is user interface. And it is at the core of our software engineering activities, because user interface are at the end the focal point for the air traffic controller, where he can access all of this information, analyze this information, and make the right decision. And so that's why user interfaces are very, very important in air traffic management, because you can design user interface to either confuse the user, and you can also design user interface to help the user. And that's why at Frequentis, we are not designing user interface in order to force the user to buy something he doesn't want. We design user interface with really the objective to help the air traffic controller to make the right decision. And that's why it's really important for us to provide the best user experience for our customers. And we are very proud of this activity because we provide user interface in various forms. You have a radar display for the air, you have radar display for the ground, you have electronic strips, you have weather information display. This is a plurality of user interface we provide, but they all respond to one and same objective: support the user and helping to make the right decision. Besides user interface, we also develop in the company flow management application and flow optimization. Flow optimization and in general flow management are applications which helps the controller to improve and actually optimize the flow of aircraft. Because it can be very chaotic if every aircraft is allowed to do what it wants. Now we provide applications which kind of optimize what is the most optimal flow of air traffic. And the effect of this application are various. It improves safety, it reduces CO2 emission, and finally, it improves the flying experience of thousands of people, because with these very tools, we are capable to reduce dramatically delays at the airport or delays in the air. And that's why these tools are also for us very important. And like trajectory prediction, like conflict detection, they rely on interesting and complex algorithms in order to provide the best sequence and the best flow to the air traffic controllers. Another interesting also field of development at Frequentis is drone management. So the usage of drone is actually booming, and if it is not done in a controlled way, it can be really chaotic. And that's why we are also developing what we call UTM systems. And UTM systems are applications which are capable really to organize and monitor all the traffic related to drone over the cities, but in the near airports. And this is also something that we develop in the company. And actually, Frequentis is one of the first company who believed in such system and developed this such application for our customers. And last but not least, it's all about digitalization, and we are also working a lot to digitalize, to provide solutions to digitalize what we call aeronautical information. So we rely on a lot of information in ATM. We rely on airspace information. We rely on routes in the air. We rely on airport information. And this is a massive amount of information which now needs to be digitalized. And we do develop application, database, tools which helps to manipulate and manage this information and distribute it to various stakeholders seamlessly. My last point, execution. And execution actually is about enabling a controller, once the decision has been made, to share it with pilots, but also with other controllers. And there are several means to share this information, obviously, but the most important one, the ultimate one, remains radio communication. And I have to say that Frequentis is the world leader in digital voice communication system. And we develop since many years highly critical application related to voice communication to allow controllers and pilots to simply communicate. And voice communication is really important. This is really the link you have between the pilot in the cockpit and the air traffic control. And for critical situation, voice communication is really the ultimate way to communicate with the pilot. And therefore, this cannot fail. And we are very proud at Frequentis to develop voice communication system which fulfill this pledge. And speaking about this pledge also does not prevent us to innovate in this field. And Frequentis introduced recently the first IoT-based voice communication in the world for air traffic control. So highly critical, extremely robust, but yet relying on cutting-edge technology such as microservices, such as containers, such as data centers. And this is the transition to the current innovation that we currently have at Frequentis, which is named Mosaics. And if you work at Frequentis, you will certainly hear about it. Mosaics is actually the platform which allows us to deploy, to execute, to manage all the applications that I have mentioned before. And the goal of Mosaics is to reconcile actually two different aspects which are mission critical application, high availability, and at the same time concepts like cloud native, CI/CDs, technologies such as container or Kubernetes into one platform. And we realize to develop this on this technology in order to provide the same guarantee of availability and confidence in the system, but yet relying on very innovative technologies. But what it is to be a software engineer at Frequentis? So in order to develop all of these applications that I have mentioned before, we rely on a wide spectrum of technologies. For instance, I have mentioned artificial intelligence for object recognition for video. But we rely on microservices architecture, on containers, Kubernetes. We work according agile methods. We are familiar with cloud native technology, data center. And if I would only talk about technology, it would be half of a story for our developers. Actually, any developer at Frequentis is part of the air traffic management communities. And being part of this community means also sharing a certain set of values that we all share. So being a software developer at Frequentis is not like being software developer in any other company. We don't develop, we don't implement application in the same way. We have values. And so what inspires our source code actually? What is important to us are this value, safety first. So in the mind of any developers, for each line of source code, we always have to ask us, is it safe? Is it reliable? Is it robust? Is it secure? And also the aspect related to human factor are also driving our implementation and driving our design. As I mentioned before, the user interface we make, are they usable for user? Do we provide the right information for the controller in the right way, at the right moment? And that's what we call human factor. And all of these values are really driving us every day. And we are all really proud But at the end of the day, really, each line of our source code matters for a lot of people. An ATM is a big family. We are not only implementing this thing for Vienna Airport or for Austria. We are actually implementing this application for the entire world. That means we do projects in every continent, but we also have a worldwide software engineering community where we can share experience, we can share knowledge with software engineers colleagues which are sitting in the US, in Romania, in Australia, and all of these people really forms one community that we are really proud of. So to conclude, really by joining us, next time you will meet your friend, next time you will meet your family, you will be able to tell them that you are contributing to make the sky safer. Thank you.